Today's topic will cover the amplitude modulation for your subject ECE 6300A modulation and coding techniques. Good morning, I'm your OSC from Engineering Department. Okay, today's topic will be amplitude modulation. Okay, first we discuss what is amplitude modulation. As you can see in this topic, amplitude modulation is a modulation technique used in electronic communication, most commonly for transmitting information via a radio carrier wave. For example, kasi meron tayong ginagamit sa telecommunication is kung paano tayo magta-transmit using modulation technique. Katulad nga ng amplitude modulation, usually ang ginagamit ito sa mga AM, wherein ang frequency ng AM or yung sa mga radio station, telecommunication is nasa kilohertz. Then through modulation technique sa electronic communication that is used for transmitting information via a radio carrier wave. Then in amplitude modulation also, the amplitude or the signal strength of the carrier wave is varied in proportion to that of message signal being transmitted. Okay, nagkakameron tayo ng modulation technique usually sa mga transmitter. Is bago ito i-transmit yung information, is i-convert ito or yung amplitude na signal strength ng carrier wave is varied in proportion that of the message signal being transmitted. Then the message signal, for example, is a function of the sound. Okay, katulad ng mga tinatransmit natin sa AM is mga function is mga sound. Yun yung mga message signal. Then this will be reproduced by a loudspeaker. Doon sa loudspeaker naman, usually sa mga receiver na yon, doon na nagkakameron ng demodulation, ika-counterpart yung pag-modulation technique. Okay, that is for example, a function of the sound to be reproduced by a loudspeaker or the light intensity of a pixels of a television screens. Kung ang pinaggagamitan naman ng amplitude modulation technique is sa mga television, is marireceive ito through yung mga television screen. That is will be received by a light intensity of pixels of television screen. Then, this technique or amplitude modulation is contrast with frequency modulation in which the frequency of the carrier signal is varied. Counterpart naman, kung sa amplitude modulation na nagbabarid is yung amplitude, dito naman sa frequency modulation or FM, in which the frequency of the carrier signal is varied. Then sa phase modulation also, wherein the phase is varied. Okay, then sa amplitude modulation from the word itself, ang nagbabarid naman is yung amplitude. Okay, that is the example of modulation in electronic communication. Next. AM was the earliest modulation method used for transmitting audio in radio broadcasting. Okay, ito yung pinakaunang gamit ng pag-broadcast or in telecommunication. Ito yung amplitude modulation. That is used for transmitting audio in radio broadcasting. Ito yung history. It was developed during the first quarter of the 20th century, beginning with Roberto Landel de Mora and Reginan Pesenden. Usually yung experiment nila yung tinatawag na radio telephone experiment in 1900. Then, it remains in use today in many forms of communication. Katulad nung ginagamit din yung amplitude modulation, katulad nung sa portable two-way radios. Okay, modulation also used in VHF, aircraft radio, citizen band radio. Then, pinagkaiba lang yan is yung sa operating frequency. Doon lang sila nagkakaiba. Then, also in computer modems in the form of QAM. Okay, next. Amplitude modulation often used to refer to medium wave AM radio broadcasting. From the word itself, ang pinaka-common talaga ng gamit ng amplitude modulation is refer to a medium waves in AM radio broadcasting. Okay, next. A continuous wave goes on a continuously without any intervals and is the baseband message signal, which contain the information. This wave has to be modulated. Okay, bago kasi tayo mag-transmit ng isang signal radio or radio wave is yung tinatransfer natin in interval or yung signal o yung baseband message signal, it is consists of the form continuous wave. Then it is continuously without any interval, then this baseband message signal contains the information. Okay, ito yung nagko-contains ng information. Then, bago siya ma-transfer or ma-transmit papunta dun sa receiver is kailangan muna natin itong i-modulate. I-modulate natin or i-convert dun sa form na pwedeng ma-transfer na siya in a form of radio wave. Yung message signal. According to the standard definition, the amplitude of the carrier signal varies in accordance with the instantaneous amplitude of the modulating signal. Okay, ito yung characteristic or yung condition wherein yung amplitude ng carrier signal, yung nagdadala ng message signal, in accordance with the instantaneous amplitude of the modulating signal is nagbabaris dito. Okay, it means the amplitude of the carrier signals varies in accordance with the instantaneous amplitude of the modulating signal. Which means, okay, ito yung definition nito, which means the amplitude of the carrier signal containing no information. Ibig sabihin yung amplitude ng carrier signal, nagke-carry na signal, it's containing no information. Varies as per the amplitude of the signal containing information at each instant. This can be well explained by the figure. Okay, para mas maintindihan natin yung definition or yung characteristic ng modulating signal at saka yung carrier signal is we have a figure for this next slides. Okay, as you can see, ito muna yung itsura nung message signal o yung signal na itatransmit natin. Okay, in this figure shows the modulating wave, which is the message signal. Okay, ganyan ang itsura ng message signal in the form of a sinusoidal waveform. Wherein yung sa X natin or yung horizontal is the time. Nakikita natin continuous, that is in the baseband signal. Then yung amplitude, yun yung AM. Okay, next. Okay, ito naman yung figure na papakita dito yung carrier wave, which is a high frequency signal and contains no information. Ganito yung itsura naman nung carrier signal. Makikita natin is madami yung kanyang sinusoidal waveform. Okay, then the horizontal axis is the time. Then ito naman yung amplitude nung carrier signal. Wherein doon naman sa kabila, ito naman yung amplitude ng modulating signal. Okay, yung pinagkaiba ng dalawa. Then, yung pangatlong figure is ipapakita na kung paano sila mag-combine through the use of modulation. Okay, ganito na yung itsura ng resultant modulated wave. As you can see, we have the horizontal axis, that is the time. Okay, ganyan na itsura ng waveform niya. Then, pinagsama na. Okay, as you can see, we have the amplitude. Ipagpa-plus lang natin yung amplitude ng carrier at saka yung amplitude ng modulating signal. Then, we have the maximum amplitude. Okay, yung pinakamataas na reach ng amplitude. Then, we also have the minimum amplitude. Then, this one is, kino-consider na natin na AM modulated wave. Yan na itsura niya. Then, ito na yung itatransmit na signal or yung waveform nung pinagsamang carrier amplitude at saka yung carrier amplitude at saka yung modulating amplitude. Okay, next. Okay, explain natin kung ano yung figure. As you can see, can be observed that the positive and negative peaks of the carrier wave are interconnected with an imaginary line. Okay, this line helps recreating the exact shape of the modulating signal. Okay, as you can see, na-observe natin yung kanina, dito is yung meron tayong positive peak at saka negative peak ng carrier wave. Then it is interconnected with an imaginary line. Then Pagkatapos nun is magkakameron tayo ng this line helps recreating the exact shape of the modulating signal. Okay, makikita natin yung shape ng positive at saka negative. Ito yung naging form para magkameron tayo ng exact shape ng modulating signal. Then this imaginary line of the carrier wave is tinatawag na nating envelope, okay? Ibig sabihin, naka-envelope na siya or naka-ready na siya para i-transmit. Since nakalagay na rin doon yung mismong message signal at saka yung carrier signal niya. Okay, that is the envelope. It is the same as that of the message signal. Okay, yung imaginary line na makikita natin dyan, that is the envelope, yung shape niya. Okay, then it has the same as that message signal also kasi nandun din naman yung message signal. Okay, ano naman yung sideband at saka frequency domain? Okay, let's explain. In radio communication, a sideband is a band of frequency higher than or lower than the carrier frequency. Okay, ang pwede kasi mangyari sa isang sideband is pwedeng yung frequency nito is mas mataas or mas mababa sa carrier frequency. That is used in radio communication. This one are the result of the modulation process. Okay, meron tayong tinatawag na sideband. Ito nga yung sideband is yung frequency can be higher or lower than the carrier frequency. Then this frequency or sideband frequency, sideband domain are results of the modulation process. Okay? After ng modulation process is magkakameron na ng sideband. The sideband consists of the spectral components of modulated signal except the carrier. Okay, ito yung definition ng sideband. It consists of the spectral components of the modulated signal except yung carrier. All forms of modulation produce sidebands. Okay, lahat ng modulation, kahit mga frequency modulation yan, or phase modulation is nagkakameron pa rin ng sideband or it will produce a sideband. Then the sideband carry the information transmitted by the radio signal. Okay, since nagkameron na ng modulation is magkakameron na ng sideband, mismo itong sideband, the sideband carry the information transmitted by the radio signal. Okay, next. Now we will discuss the amplitude modulation in results of a two mirror image sideband. Okay, ano ba yung two mirror image sideband? Okay, let's discuss. Amplitude modulation of a carrier signal normally results in a two mirror image sideband. Okay, once na nagkameron ng amplitude modulation, yung carrier signal is nagkaka-result ito ng two mirror image sideband. Okay, for example, the signal components above the carrier frequency constitute the upper sideband. Kaya nga sabi kanina, dito sa definition is, ang sideband daw is pwede siyang higher or lower than the carrier frequency. Ibig sabihin, yung higher frequency na magiging sideband is tinatawag nating upper sideband. The signal components that is above the carrier frequency constitute is the upper sideband. And then yung below the carrier frequency constitute is the lower sideband. Okay? For example, meron tayong 900 kilohertz carrier or amplitude carrier or carrier signal. Okay, that is 900 kilohertz. That is, amplitude is modulated by a 1 kilohertz audio signal. Yung 1 kilohertz audio signal, yun yung frequency ng message signal. Then, these components is mangyayari is magkakameron siya ng 899 kilohertz tsaka 901 kilohertz. Ibig sabihin, meron tayong na-create na dalawang sideband, yung upper sideband na mataas, that is yung 901 kilohertz. Then, yung mababa naman na components is yung 899 kilohertz. Okay, nagkakameron kasi ng sideband kasi sa pagta-transmit natin is meron tayong tinatawag na guard band wherein ang isang telecommunication or isang radio broadcasting is naghihingi sila ng permit sa NTC natin para doon lang sila mag-ooperate na frequency. For example, isang radio station is 97.4, is doon lang sila mag-ooperate na frequency. Yun lang yung naka-license sa kanila. Then, para magkameron ng maiwasan yung interference between other broadcasting station, is kaya nagkakameron ng sideband. Kaya usually, nagkameron ng components na 899 kHz and 901 kHz as well. It will be equal to 900 kHz in the generated radio frequency spectrum. Okay, ibig sabihin meron siyang sa left at saka sa right, or yung mababang frequency at saka yung mataas na frequency na nasa range ng 900 is doon lang sila mag-ooperate para maiwasan yung mga interference with the other radio station. Okay, that is the application of a sideband. For example again, so an audio bandwidth, okay, meron tayong bandwidth na 7 kHz, will require a radio spectrum bandwidth of 14 kHz. Okay, makikita rin natin dito yung application na tinatawag natin na nagiging doble kung meron kang audio bandwidth na 7 kHz para sure na mataas yung kanyang bandwidth or mabilis yung transmission ng data or ng signal is nagkakameron tayo ng spectrum bandwidth na 14 kHz. Nagiging doble lang siya or times 2 lang natin. For example again, in a conventional AM transmission as audio as used by the broadcast band AM station. Pag sinabi natin broadcast band AM station, usually ito yung mga conventional AM transmission. That is, the original audio signal can be recovered and detected by other synchronous detector circuits or by simply envelope detectors because the carrier and both sidebands are present. Okay, yun na nga yung application ng sideband. Okay, katulad dito, sa conventional AM transmission, ang original na audio signal is, for example, can be recovered or ma-detect ng synchronous detector dun sa receiver, is kailangan meron tayong simple envelope detector na ginawa dun sa transmitter. Because the carrier, okay, yung carrier dun, tsaka yung both sideband are present naman dun sa envelope. Kasi yun kasi ang binabasa ng receiver, yung sideband at tsaka yung carrier na makikita naman sa sa envelope. Okay, that is done by the synchronous detector. This is sometimes called the double sideband amplitude modulation. Okay, nagkakameron din ng double sideband amplitude modulation. Kapag ang nadidetect is yung carrier at saka yung both sideband are present. But not all the variants of DSB, double sideband, are compatible with envelope detector. Okay? Yan yung limitation din. Hindi lahat ng mga variants ng double DSB are compatible with envelope detectors. Okay, next. In some forms of AM, the carrier may be reduced to save power. Then the term DSB is reduced carrier normally implies enough carrier remains in the transmission to enable a receiver circuit to regenerate a strong carrier or at least synchronize a phase lock loop. But there are forms where the carrier is removed completely, producing a double sideband with suppressed carrier. Okay, meron tayong tinatawag ng mga ibang form kasi ng mga double sideband or single sideband. For example, in some forms of AM, pwedeng i-reduce or bawasan yung carrier. Pag na-reduce yung carrier or yung mismong carrier signal, is mangyayari is makakasave tayo ng power. Okay, that's one application. Then another application is the term DSB, double sideband reduced carrier. Pag sinabi natin double sideband reduced carrier is yung carrier is na-reduce. Bakit kailangan na-reduce? Para ma-save yung power. Kasi pag nagtatransmit tayo, is gumagamit tayo ng kailangan na mataas na power. that is used for long distance. Kasi long distance yung transmission or bato natin ng signal information. Okay, that is the term double sideband reduced carrier. Normally implies enough carrier remains in the transmission to enable a receiver circuit to regenerate a strong carrier. Okay, yung advantage nun ng DSB reduced carrier, or at least synchronize a phase lock loop, but there are forms where the carrier is removed completely. Meron din namang mga forms na hindi lang binabawasan yung carrier, is completely removed. That will, pag na-complete na remove yung carrier, ang tawag na doon is, it will producing a double sideband with suppressed carrier. Okay, DSB, SC na ang tawag sa kanya. Okay, next. Suppressed carrier systems required more sophisticated circuits in the receiver and some other method of deducing the original carrier frequency. For example, the stereophonic difference left and right, LR, information is transmitted in a stereo FM broadcasting of 38 kHz subcarrier where a low power signal and a half the 38 kHz carrier frequency is inserted between the monaural signal frequency. Then, this will range up to 15 kHz and the bottom of the stereo information subcarrier is down 38 to 15 kHz. For example, is yung 23 kHz frequency. Okay, makikita lang natin dito is paano nagkakameron ng for example, yung monaural signal frequency is nasa rin siya ng 15 kHz. Pero meron siya ring value ng bottom ng stereo information subcarrier naman is down to 38 to 15 kHz. Okay, ibig sabihin may range sila na frequency. Okay, then makukuha naman yung pinaka frequency is yung nasa 23 kHz frequency. Okay, next. Kaya importante kasi yung meron tayong range ng frequency is para doon lang mag-transmit or exact yung transmitter at transmission na frequency na paggagamitan. Okay, next. For example, the receiver locally regenerates the subcarrier by doubling a special 19 kHz pilot tone. Okay, meron tayong tinatawag na pilot tone para sa receiver is para ma-regenerate yung subcarrier is dinodouble niya yung special 19 kHz pilot tone. Kaya usually pag tinimes to natin yung 19 kHz is makukuha nating value is nasa 38 kHz. Okay? Kaya yung stereo information is nandun pa rin siya. Kaya meron tayong tinatawag na pilot tone. Para yung sa receiver is the receiver will locally regenerate the subcarrier. Okay, para ma-regenerate ng receiver yung subcarrier by doubling a special 19 kHz pilot tone. In another example, the quadrature modulation naman is used historically for chroma information in a PAL television. Okay, para sa mga television natin na ginagamit na condition or mga settings is naka-PAL television broadcast, gumagamit tayo doon ng quadrature modulation para sa mga chroma information ng PAL television broadcast. Then this synchronizing signal is a short burst of a few cycles of a carrier during the back purge, then part of each scan line when no image is transmitted. Okay, that is a quadrature modulation. Okay, next. But in other DSB, double sideband suppressed carrier system, the carrier may be regenerated directly from the sideband by a Costas loop or squaring loop. Okay, may ginagamit kasi na application para doon sa mga katulad nung sa DSB double sideband suppressed carrier system. Para mabilis ma-generate yung carrier is the carrier may be regenerated directly from the sideband by use of a costap loop or squaring loop. Okay, yun yung ginagamit. Next, sidebands are evident in the spectrogram of an AM broadcast. Okay, if part of a one sideband and all other remain, it is called a vestigial sideband. Okay, kung ang isang sideband naman, kung isang part, since dalawa yung sideband, sa upper sideband at saka sa lower sideband, if part of one sideband, merong isang sideband, saka yung other also of the sideband is remain, ang tawag na doon is yung tinatawag nating vestigial sideband. Kaya ano ba yung vestigial sideband? It is used mostly with television broadcasting, which will otherwise take up an acceptable amount of bandwidth. Okay, ginagamit natin sa mga television broadcasting with an acceptable amount of bandwidth. Transmission in which only one sideband is transmitted is called single sideband modulation or SSB. Pag-transmit naman, if the transmission in which only one sideband is transmitted, it is called single sideband modulation or SSB. Okay, yan yung SSB. Isang sideband lang ang tinatransmit sa transmission. SSB is the predominant voice mode on a shortwave radio other than a shortwave broadcasting, since the sideband are mirror images, which sideband is used as a matter of convention. Okay, nagiging convention yung sideband dito sa single sideband. It is the predominant voice mode on a shortwave radio other than shortwave broadcasting. Okay, para sa mga shortwave broadcasting, ginagamit yung single sideband. Okay, let's continue. In single sideband, the carrier is suppressed, significantly reducing the electrical power by up to 12 decibel without affecting the information in the sideband. Okay, yun yung ginagawa sa single sideband application. The carrier is suppressed, then significantly reducing the electrical power by up to 12 decibel. Okay, pag nasuppress yung carrier, if the carrier is suppressed sa single sideband, it will produce or reducing the electrical power by 12 decibel. Also, without affecting the information in the sideband. Okay, next. This makes more efficient use of a transmitter power and RF bandwidth. Okay, nagiging mas efficient paggamit ng transmitter power at saka RF bandwidth kapag ang ginagamit natin ay single sideband. But a bit frequency oscillator must be used at the receiver to reconstitute the carrier. Yun nga lang, kailangan gumamit ng bit frequency oscillator dun sa receiver on the demodulation technique para ma-reconstitute the carrier. If the reconstitute carrier frequency is wrong, then the output of the receiver will have wrong frequency, but for speech, small frequency error are no problem for intelligibility. Okay, nagkakameron kasi ng problema kapag katulad dito, hindi na reconstitute yung carrier frequency. If the reconstitute carrier frequency is wrong, mali, then the output of the receiver will have a wrong frequency. Okay, yun yung nangyayari. But for speech small frequency error are no problem for intelligibility. Pag mga speech lang yung mga paggagamitan or speech small frequency errors, is hindi ito nagiging problema for intelligibility. Okay, next. Okay, for example, another way to look on single sideband receiver is an RF2 audio frequency transposer in a upper sideband mode. Okay, that is the example. The dial frequency is subtracted from each radio frequency component to produce a corresponding audio component, while in lower sideband mode, each incoming radio frequency component is subtracted from the dial frequency. Okay, so mga dial frequency, it is subtracted from each radio frequency component to produce a corresponding audio component. Sa lower sideband naman, mode, each incoming radio frequency component is subtracted from the dial frequency. Okay, continuation of a sideband. Sideband can also interfere with an adjacent channel. The part of the sideband that will overlap the neighboring channel must be suppressed by a filter before and after modulation and often both. Okay, sa sideband kasi, para maiwasan yung interference of adjacent channel or adult channel, yung part ng sideband that will overlap the neighboring channel must be suppressed by filter. Gagamit tayo ng filter sa before and after modulation and often both. Okay? In broadcast band frequency modulation, subcarrier about 75 kHz are limited to a small percentage of modulation, and it is prohibited above 99 kHz altogether to protect yung normal deviation na positive plus or minus 75 kHz. Normal deviation, constant yan. Tsaka yung 100 plus or minus 100 kHz channel boundaries. Kaya nga kanina bumaba yung frequency at tsaka meron siyang pataas, tumaas din. Kasi nga nagkameron tayo ng 100 kHz channel boundaries. Okay, that is in the broadcast band frequency modulation. The subcarrier, constant yan, is above 75 kHz are limited to a small percentage of modulation. Then it's also prohibited above 99 kHz. Okay, dapat hindi sobra sa 99 kHz yung broadcast band frequency modulation. Or yung ating subcarrier, hindi dapat lalampas doon. Naka-prohibited lang siya sa 99 kHz. That is, altogether, to protect the 75 plus or minus 75 kHz normal deviation. At saka yung sinabi ko kanina na plus and minus 100 kHz channel boundaries. Okay, that's why it is important that the subcarrier should be limited to a small percentage of modulation. Okay, next. Frequency modulation also generates sidebands. Then the bandwidth consumed depending on the modulation index, then often requiring a significant more bandwidth than the double sideband. Then the Bessel function can be used to calculate the bandwidth requirements of an FM transmission. Okay, sa FM transmission naman, or sa frequency modulation is nagkakameron din ng or nag-generate yung sideband. Then, yung bandwidth dito sa frequency modulation, it is consumed depending on the modulation index, often requiring significant more bandwidth than double sideband. Then, para makalculate natin yung required na bandwidth sa FM transmission, is gumagamit tayo ng formula na Bessel functions. Sa amateur radio and public services, FM transmitter are generally utilized. Ang deviation nito is plus and minus 5 kHz. Okay? Plus and minus 5 kHz deviation. Next. Okay, ito na yung mga formula na tatandaan lang natin sa communication or sa modulation encoding technique. First is the equation of the amplitude modulated wave. Okay, ibig sabihin ito yun. S of t equals to AC cosine 2 pi fc of ct plus AD over 2 cosine of 2 pi times 2 pi times f of c plus f of m times time. Then doon naman sa kabila na cosine function. That is AD over 2 times cosine times 2 pi f of c minus f of m times time. Okay, yan yung pinaka-equation ng amplitude modulated wave. Okay, ito naman yung nagiging formula ng power total. The power of an AM wave is equal to the sum of the power of the carrier. Okay, power total is equals to power ng carrier, power ng upper sideband, then power ng lower sideband. Okay? Next. Okay, this one is the standard formula for a power of cosine signal. Okay, ito yung formula. Sa VRMS, that is RMS value of cosine signal. Sa BM naman, that is the peak value of a cosine signal. Where P, yung formula ng power natin, that is BRMS squared over R, then equals to BM over square root of 2 squared over 2. Okay? Kasi ang BRMS equal siya sa BM over square root of 2. Where BM is the peak value of the cosine signal. Then BRMS is the RMS value of a cosine signal. Okay, these are the topic now. Next topic will be the modulation index. Okay, ano naman yung modulation index? Modulation index is a carrier wave after being modulated. If the modulated level is calculated, then such attempt is called the modulation depth or modulation index. Okay, sa mga ibang libro, tinatawag natin siyang modulation depth or same lang siya ng modulation index. For example, in a carrier wave, after being modulated, if the modulated level is calculated, then such a term is called modulation depth. Okay, ang modulation index, by the definition, it states that the level of modulation that a carrier wave undergoes. Okay, dito natin malalaman yung level ng modulation that a carrier wave undergoes. Okay, yung formula rin, where S of t equals to, sinimplify na, A of c times 1 plus micro cosine 2 pi fm of t, then times cosine 2 pi f of ct. Okay? Next. Okay, yung micro is the modulation index. Okay? Usually, modulation index is naka-ratio siya. I-divide lang natin yung AM, that is the amplitude ng modulating signal, divide it by the AC, that is the carrier amplitude. Okay? Ulitin ko lang, that is modulation index equals to AM over AC. Modulating amplitude over carrier amplitude. Then, ang pinaka-simplify na formula ng modulation index is A max over A mean over A max plus minus A mean. Okay, ano lang dito. Okay, check lang natin. Okay, then the modulation index and the modulation depth is often denoted in the percentage called the percentage of modulation. Then we will get the percentage of modulation just by multiplying the modulation index value with 100. Okay, multiply lang natin sa 100 para makuha yung value. Okay, for a perfect modulation, the value of modulation index should be 1. Okay, para maganda yung pagkaka-modulate ng isang signal or yung modulation natin, it should be modulation index should be 1, which implies the percentage of a modulation equals to 100. Okay, next. Okay, ito na yung mga definition ng modulation or undermodulation or overmodulation. For instance, if this value is less than 1, the modulation index equals 2.50. Okay, pag less than 1 siya, ibig sabihin, then the modulated output will look like the following figure or tinatawag nating undermodulation since it is less than 1. Okay, ganito ang itsura ng undermodulated wave. Okay. Okay, dito naman sa figure, if this is greater than 1, this will be equal to 1.5. Okay, ganito naman ang itsura ng overmodulated wave. Okay, bakit kailangan natin malaman yung modulation index kung overmodulated siya or undermodulated? For example, as the value of modulation index increases, the carrier experiences a 180-degree phase reversal which causes additional sidebands and hence the wave get distorted. Okay, kapag ang modulation index natin is naging overmodulated, is nagkakameron ng yung carrier is nagkaka-experience ng 180-degree phase reversal. Then this 180-degree phase reversal, this will cause additional sideband. Then since nagkameron ng additional sidebands, ibig sabihin yung waveform natin or wave is magiging distorted. Pag sinabi natin distorted is sira yung signal or hindi maayos yung pagkakagawa ng signal sa modulation through a modulation process. For example, kung sa television, distorted yung signal, marireceive natin sa receiver doon ng television is malabo or maraming snow na itsura doon sa picture ng video ng television. Such an overmodulated wave cause an interference also. Nagkakameron din ng interference yun nga. Then, malabo yung nakukuha, nasasagap na signal. Then, hindi naman may iwasan or which cannot be eliminated.